Okay, great. Let's get kicked off before we run out of time. So, hi everybody, my name's Owen Hawkins. I'm a Principal Solution Architect at AWS. What I have to do now in AWS terms is tell you how long I've worked for AWS. I don't know why we always do that, but we always do that. So I'll stick with tradition. So I've been with AWS about 4 years. Before that, I worked in the financial services industry. And before that, back in the good old days, I was an application and penetration tester. With me today is Adrian Asher, who is the CISO and lead cloud architect at checkout.com. Adrian's going to introduce himself much better than that in a few minutes, but I'm just going to give you a quick overview of what we're going to talk about first. So, I'm going to give you here a definition of modern application development. Now, I don't love this definition because I don't think any of us, even old people in the room like me, started out writing legacy applications. We all thought we were writing a modern application at the time we were doing it, even when we were then running it on the mainframe 30 years ago. So the definition we're going to use today, though, is thinking about modern application development as an approach to designing, building, and managing the applications. And the purpose of this is increasing our delivery speed and improving the reliability, the scalability, and most importantly, for what we're going to focus on today, the security of our apps. So we're going to talk about the development framework, the process we go through to develop these applications, rather than diving deep into the applications themselves in this session. So we're going to start off talking about software release processes and application security, the steps we can take throughout that process to help protect the security of the application. We're then going to move on to how we can apply similar processes to our infrastructure management. And then the last part is we'll take an example app. It's a very simple app, I'm not going to lie, but we'll take an example app and we'll go through some of the controls that you might want to think about when you're building those apps. And then we'll move on to some takeaways. So, Adrian, over to you.
Thanks, Aaron. So I'm Adrian Asher. I'm the CISO and cloud architect at checkout.com. Been a CISO and working in security for 2.5 decades now, so I agree with the not thinking it was old at the time we were writing it. I've been CISO at various places, banks, stock exchanges, startups, all over the place. But checkout.com is an online payment processor. So we have licenses for acquiring in over 50 countries. If you do food delivery online, like Deliveroo and things like that, you might be using our systems, Sainsbury's, TransferWise, or Wise as it now is. So a large number of very enterprise class merchants use us to process payments fast, but securely as well. We've got a great team. We've had a recent all hands, and that's the photo from it with our CEO, Guillaume, at the front. But we've got great merchants as well, and so we really stand behind the brands that we get to enable them to do online payments in the sort of digital marketplace and really sort of thrive. We're where the world checks out.
Okay, thanks, Adrian. So what we're going to do now is we're going to start off with talking about software release methodologies and application security within that. So let's think about where this problem is. What's the problem statement that we're trying to solve here? What I've got here is a little graph that gives you an example of the number of services that AWS is rolling out, right? So this is about the size of the problem, why you need to develop applications quickly and obviously securely at the same time. So you can see we started off with tens of releases back in 2011, and now we're at sort of 3,500 services and features being released a year. Now bear in mind, that's new services or new features inside services. That's not bug fixes, it's not minor releases, it's not those minor changes that we need to do all the time. So we're writing that many features and services. We need to think about how we can make sure that we're developing and deploying applications quickly and securely. And that applies to you as well. Everybody's application, the best thing you can do is get that application available to your customers, reduce that overall time, and speed up the cadence that you're making those releases. Now, if we think about traditional application development, we typically had a manual software release process or a manual development cycle. So we would go through our application, we develop the application, we then start building into our build environment, we go through a build process, then we do some testing, and then we deploy it manually onto the tin. It's really hard in a lot of those processes to actually identify potential issues. What we tended to do is we tended to push back that security testing to the end of that process. So it means you've got a big loop to go back around in order to continue and update that release and fix the problem that you found. And that manual software release, I don't know how many of you have been through that process. I certainly have. It was so error prone. The chances of having a release that went into live then you've got to roll it all back and redeploy it because you made a problem during that manual process, was massive. So changing that to automation improves that speed and improves the reliability. So what we're going to talk about in our context today for modern application development is this pipeline. So we're going to develop, we're going to do some source control and some source code management. We're going to have a build process, we're going to test, and we're going to deploy. Hopefully this is pretty familiar to everybody. It shouldn't be anything new and scary here. But we're going to think about where we can check for potential security issues throughout this process and how we can look for tooling that will help us in that process to make sure that we're applying those security controls as early as possible in the process. Because that helps us fix things faster. If I fix something in the development stage and I'm still writing the code and I get a warning that says, this is wrong, you should fix it, that means it's fixed very quickly. If I've gone all the way to the end of this test cycle, that takes much longer. And that's what used to happen, as I say, in traditional application development. We did our development, we checked it in, goes into the build process, and then somebody like me used to arrive and sit on your data center floor for a couple of days and actually do the testing of that application in your live environment or in your staging environment. At that point, I used to scare project managers by saying, here's a list of all your pen test findings that you now need to go and fix before you can go into live. But the effort then to go back into that full release cycle is a big deal. Actually having to make those changes, put it back through testing and redeploy, takes a long time. So it would have delayed that cadence. So even when we were operating on slower release cadences, they could be delayed even further because we're pushing that security testing back. It meant that we were failing very slowly. We weren't quickly getting the results back of our testing and being able to adapt to it. Obviously it costs a lot more because we've got to go back through a lot of test phases, and it slows us down. So we need to think about how we can shift all of this to the left. We need to think about how we can get faster software releases, increase our productivity, and find those vulnerabilities early on, because the closer to the left of that diagram that we can find them, the quicker we can fix them. Now, I'm sure people will have heard the phrase that at AWS, everybody owns security. Yeah? We used to say a slightly different phrase that I'm not going to repeat, that we moved away from because it made it sound like nobody owns security. Everybody at AWS owns security. And that's a really important thing for this session to think about, is operationally how you think about security. If you're a development team building an application, you should then own that application into live and own the security of that application. What used to happen years ago is you'd go through that security testing cycle I talked about, and then you'd go to your security team and say, can you give me sign off ready to put it into live? Actually, move away from that mental model. The mental model should be that it's the application development team who own that security process, and they're responsible for the security of the application. If you find a vulnerability, it's them that own it, it's them that fix it, it's them that release it into live. Not only because they're then incentivized to own their security, but also it means that there isn't a security team just saying no. That is never the answer, that a security team should just be saying no. What happens in our case, AWS Centralized Security, they still exist, but the idea is they're empowering those development teams to be able to say, well, this is how you could fix that problem. This is the enablement that you need, or the tooling that you need in order to resolve that situation yourself. So, I'm going to cover a few things in our pipeline testing today. This is a little summary of them, but we're going to go through each of these in process, just so that we can get a look at them. So, we start off and we've got some requirements and a design. Great, that's always a good place to go. The first thing that we should be thinking about really then is starting to model out the threats that our application is likely to have. And I know a lot of people talk about threat modeling, but I haven't seen that many people in action doing it. So the purpose of that threat modeling is to help you determine what are the threats that apply to my application. Am I writing an application that's going to control a nuclear power plant? I've got one set of threats. Am I writing a website for my cat? Different set of threats. Thinking about who the threat actors are, what applies to your application, and what controls you've got in place that you're comfortable and familiar with that you could use to prevent those threats from occurring is a really important process. Now, we've got some tooling that I've mentioned here, Threat Composer, that you can use to do that. I've seen people do it in Excel spreadsheets, I don't recommend it, but it's doable. There's lots of other tooling around as well, right? OWASP Threat Dragon is a great example as well of another open source tool that you can use to do that threat modeling. But actually, making sure that you're identifying and closing off those threats, or at least working out what your response is to those threats, is really important. Because if I develop a whole feature, I get to the end and think, well, actually my design was flawed, considering I have this particular threat in this application, you're throwing the whole thing away and starting again. So I've got a developer. They've probably got an IDE. They've probably got some local tooling, weird and wonderful local tooling in my experience. Everybody likes their own things. And then we've also got some code, hopefully. That's the point, right? So when the developer's working on that feature or task, they're often asked to write secure code, but what tooling do we have that can help them in this phase? So this is where Code Whisperer and Amazon Q Builder come in that you can use them to do security scanning of the code you're writing and give you in-context recommendations of how to develop that code and deploy that code. The purpose here is that you're also scanning all of the libraries that you're calling into that ID as well, because obviously we've got all the links inside the code, so we can follow the links as well and look inside the libraries that you're using. So this is where Code Whisperer can really help you. We're also going to talk about the integration into Amazon Code Guru Security in a second as well. So if we move on from that development phase into the source phase, so this is where we're checking in that source code, checking it to our code repository. Now, what we might want to do here is we might want to do a peer review. It'd be a great time to have somebody else just check over our code, make sure that everything we're doing is valid and sensible. But the other thing that we want to do at this point is make sure that we haven't got anything in our code that we shouldn't have. I'm sure everybody's seen exposures where there's been somebody's access keys or somebody's secrets are published into the code repository and then that's leaked online. This is the place where we can check for that process to make sure that that's not happening. So we can use a pre-commit hook on our check-in to the source code repository to validate at that point that there is no secrets inside that information that's being passed in. We can also use it to scan the code repository. So we could use a static application security analyzer to check the whole repository and look inside the repository after things have been checked in. So what's the purpose of that static application security testing? I'm sure everybody, I hope everybody in the room's heard of OWASP's top 10. So what that's doing is that's giving us some ideas about common problems inside applications. So using a static application security testing tool, I'm going to stop saying that now and start saying SAST, enables us to check our code repository or check when we're checking it in to validate against common problems. The one that I see people less frequently are familiar with is that common weaknesses enumeration top 25 that's mentioned up there. So that's a MITRE list, very similar to the OWASP one, but it's not specific to web applications. So it covers some of the same things because obviously lots of applications are web applications, but it also covers other types of applications that aren't web specific. We talked about secrets management, sensitive data being in that code as well. That's what we're talking about, that log injection secrets. And then thinking about the secure use of your APIs, particularly access keys, things like that from an AWS point of view. So this is where Code Guru Security can help us. So it is a SaaS tool that's using machine learning. It wouldn't be an AWS presentation today if I didn't mention Gen AI or machine learning at least twice, right? And we're using that automated reasoning to reduce the false positives that you see inside it. And then it's got an API-based design that enables you to flexibly integrate it into your process. And we'll talk about how we can do that in just a second. One of the things that's really great about it as well is that it can actually go through some of the bug tracking process and fix bugs automatically and check that code back in on your behalf. So you might want to go through and then validate that that is a fix that you want to accept, but it will automatically fix the code and put a new check in that you can then accept or deny. So here's just a little example of a Code Guru security finding. In this particular case, it's for weak encryption. But you can see up there on the top left is a description of what the problem is. You can see the affected snippet at the bottom. And on the right-hand side, we've got that example set of code that you can link through to. So you can go and get help on how do I resolve the problem that's being called out by Code Guru Security. In terms of the workflows, if you're a masochist, you can go into the console and copy and paste your code into the console. I really wouldn't recommend doing that, but it works. You probably want to think about how you can build that into your pipeline, either using that pre-check-in hook that I talked about, or also having that built into your IDE in the first place. So there are IDE integrations that you could use instead. Okay? So thinking about how you can apply that testing as far to the left as possible is the important part here. So you're doing your SAS testing, you're getting your recommendations from Code Whisperer as well. So we've got some code, we've checked it in, we've evaluated it. Now what we're going to do is we're going to look at how we're going to build that code. I've put code build up here. Obviously there's lots and lots of other tools that you could do that with instead. But we've talked about SAST, but we might want to use tools with a slightly different focus here. So rather than looking specifically at that code, I might want to look at different parts of the coding here. I might want to get a good understanding of what are the pieces of software that are making up my application. So I've got my application, I've written the code, that's great. I'm pretty confident that not many people have written an application where they literally write every line of code and they're not using any external libraries. So thinking about what the risks are from those external libraries means in the first place, I have to understand what external libraries I've got. So that's one of the places where Amazon Inspector can help us. So if you're not familiar with Amazon Inspector, essentially it's a service that can detect software vulnerabilities and unintended network exposures in near real time on EC2, on Lambda, or on container images. So the slide I've got up here, just to show you an example, is over there on the right-hand side. If you use Amazon ECR, you get basic scanning of the OS packages in your containers for free as part of ECR. Okay? We can apply an enhanced version of that using Inspector. And at that point, what Inspector will do is it will look at those containers, and it will look at not only the OS level, it'll also look at the languages and the code that's written inside that application as well. And then over on the left is for Lambda. Inspector will do code scanning against Lambda as well. So it will look into the code itself and give you recommendations for fixes there as well. Another key part, as I mentioned, is that we can build up a software bill of materials. This is that list of all of the application components inside your application. So if you think about the Log4j problem a couple of years ago, it's very easy for you to determine where you've used Log4j inside your part of the application. Where you've pulled in an application library and it's used Log4j is much harder to determine. And that's the idea behind an SBOM, is to actually take you through the full list of all the software that you're using. And you can use that with your threat model to determine what exposures you've got based on new information that comes out. So if you know you're running a certain library, a new CVE comes out for that library, you know if you've got to do an incident response on that or not. So this is about making sure you really understand what software am I running in my application. You can also use QuickSight and Macy to search through that. There's a visualization using QuickSight, which is pretty cool, that you can then dive into different parts as well. So it means you can expose that to teams that probably don't understand those CycloneDX and SPDX formats themselves. So we've developed our application, we've built it. Now we're going to put it into the test environment. I'm not going to talk much about dynamic application security testing, DAST. The important part I wanted to call out here, though, is why it's different from SAST. So what we're talking about with static is we're talking about looking at the code itself and trying to determine vulnerabilities inside the code itself. DAST, I find, is quite often misunderstood, but the idea behind DAST is that you're running it in the environment. You're running the code in an environment, and that's taken into account when you're doing your DAST testing. So if you think about things like OWASP ZAP, you're passing requests to an implementation of that application that's running in a representative environment, and you're running it in the context of the environment. Yeah? So you're dynamically assessing the whole environment rather than just statically looking at the code. Okay? So I go through some dynamic testing. Sorry, should have mentioned the last part. You can tell why I'm not a pen tester anymore. That's also where you do your pen testing still. Pen test companies are available still, it's fine. So you do your dynamic testing, and then at that point, you go into live. Brilliant. We're done. But obviously we're not done. We're never done. Threat landscape changes all the time. We need to keep assessing for new problems. So continuously looking at what's going on is incredibly important. So continuous scanning, Inspector, again, you're doing continuous scanning, perhaps of the live environment at that point. Also using things like guard duty. Guard duty can be a really good indicator here that there's a problem going on inside our environment. and can help us call out those anomalies or vulnerabilities. So, hopefully we've been through all the things I said we were going to talk about on that slide now. We're going to come on to talk about infrastructure management instead. So we've just talked about traditional application development, and we've talked about automated application development. Now, even in some companies who have an automated deployment process or an automated software development lifecycle, I still see a huge number of people who are building their own servers to then do that deployment onto. I need an RDS database. I'm going to get my RDS man to build me an RDS database, or RDS lady to build me an RDS database. I'm still building the infrastructure manually and then deploying the application onto it automatically. So we need to think about applying these same processes to our infrastructure as well. Still hugely inconsistent, so easy to misconfigure if I'm doing these steps manually. So I'm sure it'll come as no surprise to most of you that I'm going to mention infrastructure as code here. So let's think about how we could use infrastructure as code in a similar way to we talked about with our application to deploy the infrastructure in a consistent way with those checks in at every part of the process. It means I can reduce the chances of misconfiguration, and it also means it's much easier for me to enforce security measures across the infrastructure that's been developed. If you think back to security being everybody's problem, think about that centralized security team. What they can do inside an infrastructure as code pipeline is they can help implement guardrails that protect the developers. Yeah, it makes an awful lot of sense to have a set of guardrails that are in place so that the people who are expert in that security area are applying the guardrails that means people can't get themselves into trouble throughout that process. And I'll talk about how they can do that.
We like to say that's why you have brakes on a car, because if you didn't have brakes on the car, you wouldn't want to drive very fast.
Exactly.
So these guardrails help you go faster.
So we need to treat the infrastructure the same way the developers treat the code. I'm going to take an example. We're going to use CDK as my example. You could use Terraform if IBM haven't bought it yet. You could use CloudFormation, obviously that's great as well. So I'm just going to use CDK as my example because I happen to like CDK. One of the reasons I like it is it's hugely more succinct than using CloudFormation. So my 20 lines of CDK here is about 500 lines of YAML in CloudFormation. So it makes my life easier when I'm writing it. But the same processes still apply. I can still use Code Whisperer and Code Guru Security and whatever local tools I like when I'm developing that code. I can still use SAST in that source control phase in the same way. Yeah? Pre-commit hook, check it with the SAST tool before it goes into the repository. Where we start to deviate a little bit is when I get into that build process. So I might still do some SAST, but one of the other things I might do at this stage is some policy validation. So what I mean by that is determining what is allowed inside those IAC constructs that we're using. So just to give an example, if I'm going to use the infrastructure as code to create a VPC, I might decide that I only want VPCs that start with subnets that start with 11, just because I've decided that. But I can define that as a policy, and then I can enforce this throughout that process. So some of the tools that I mentioned there, CloudFormation Guard, which I'll talk about a little bit further, Open Agent Policy, Open Policy Agent, or CDK NAG, right, are mechanisms via which I can write those policies that could be determined by that centralized security team or in conjunction with the application development teams, but then enforced throughout my pipeline process. So I define a set of policy, again as code, and then I validate that policy at this stage in the process. Yeah? So this is hugely powerful if you think about it from an architectural point of view as well. I've never met somebody who hasn't been on some kind of architecture course who hasn't used the term system building blocks. Yeah, this is how you can define those system building blocks in code that you then want your developers to use. If you think about the way a lot of IT departments are split up, if you've got a platform team that are defining strategies and architecture centrally, they can enforce that via guardrails in that policy as code. And the development teams can then pick that up and will automatically implement them. Okay, so we've been through and we've built and we're going to go into test. Still talking about Inspector, still talking about DAST. Great. I'm going to give an honourable mention to a much maligned AWS service here. IAM Access Analyzer is a great service that people tend to look at once and then never really go back to again. What IAM Access Analyzer is helping you do is work towards zero trust. I'm going to use zero trust a lot now, and that's very marketing-y as well, but it's not this year's like Gen AI, but it's still very marketing-y. The purpose of Access Analyzer is it will look at the roles that you've assigned to your infrastructure, and it will say that role has never used that permission. Yeah, I've got an EC2 instance that I've given access to Adrian's S3 bucket. But that EC2 instance has never called Adrian's S3 bucket. So Access Analyzer will say, do you really need that permission? I'd recommend you change your policy to remove that access because you're not using it. Yeah? So that helps you refine that policy over time. And we are going to have some IAM policies on screen in a minute or two. I appreciate they're not everybody's bag, right? And they are quite hard to follow, particularly when you're first picking them up. But that's why this tooling exists, is if you start off with an overly permissive policy, it'll help you reduce down that permission set over time. Now my clicker's not working, there we go. And then once I move into the deployment phase and I've deployed my code, we're in that operational phase now. I mentioned guard duty earlier on. Guard duty, obviously from an infrastructure point of view, even more powerful, looking at my EKS logs, looking at all of those other things that guard duty looks at. It's a great service, loads of development on it recently, so well worth a new look if you haven't looked at it for a while. But the part I want to mention here is also config and CloudFormation drift detection. So once I've been through that pipeline process with my IAC, I've defined what the pipeline is going to look like, and I've defined what the controls are I want in place. Checking that I haven't drifted away from the things that have been implemented is what config and CloudFormation drift detection are doing for me. Making sure we haven't changed it in live manually after we deployed our IAC. So thinking about how we can move all those things left, whether it's application or infrastructure. Last part, and I promise Adrian's going to get to talk in a minute. The traditional application development. So what we're talking about here is we're talking about an example application. So when we used to write applications and even infrastructures, we would focus very much on perimeter security. There didn't tend to be that much focus on security inside. We now need to think about that across every single layer. How do we make sure that we've got redundancy of security controls throughout our layers, but also we're enforcing granular control to make least privilege more and more applicable, more usable. Told you I was going to do zero trust again. Here's my zero trust definition. This is the AWS definition of zero trust. Others are available. You can ask your favorite Gen AI tool to tell you a zero trust definition if you'd like. But the thing I want to focus on just inside this, and before I hand over to Adrian, is thinking about not just network segmentation, but how you tie your authorization into the segmentation. So you're tying the two things together. I don't just have a firewall that says yes or no you can get access. I have an authorization layer tied to my networking that determines how you get that access.
Thank you, Owen. So infrastructure is dying. It's something I've been saying for many years now. But what does that mean? Well, Owen mentioned that you need to move from the perimeter down to micro-segmentation. We should really just have a perimeter that's around every piece of data, every identity that we want to protect. But how do you do that? So we really focus on how can we use cloud-native techniques as opposed to what I call cloud-naive techniques. So if you're using IaaS, if you're manually configuring your environment and not using Terraform or CDK like Owen mentions, then I say you're doing cloud-naive. And to shift to a cloud-native approach, you need to be able to use modern techniques and patterns in order to finish killing off the infrastructure. So it doesn't differentiate me or my teams to have to manage IP addresses between different services. And yet we have to do that if we have lots of transit gateways everywhere and lots of VPC peering, heaven forbid. So really what we've been looking at since 2022 when Cloud WAN came out was how can we start putting some of our defense in depth, our policy as code into practice. And AWS Cloud WAN is one of the techniques that we're using and exploring to be able to do that. So on the screen here, which is very small, you'll be able to see the different OUs that we have. So we have a number of testing environments, we have a number of development environments, we obviously have a number of production environments as well. And we want to keep those all as separate as possible. We want to have a number of accounts as well. So we want to have accounts that are used just for dev maybe, or just for prod, in addition to having an OU within AWS organizations that applies all those guard duty rules that Owen mentioned. So this is how we're doing it. So at the top, you can just about see we're using something called Account Factory for Terraform. And what this does is allows us to build and spin up new AWS accounts using Terraform. So we write our code to actually get a new AWS account, we commit it through code pipeline, we then get AFT to pop out with a brand new AWS account. That's great. It's empty, we can't do anything with it. So now we want to be able to use that account. So if we want to use Cloud WAN, we want to provide connectivity options between that new account and the existing accounts, which might have some services that we want to consume. Well, let's say it's a dev environment. Yes, I could go and then raise another pull request on another repo to actually allow that connectivity between this brand new account and my existing dev accounts. But that's taking time. That's taking, at the moment, human effort to do. So one of the things that we're doing with Cloud WAN, if we could go on to the next slide, is we're putting some of the policy into code. So on the right here, what you can see is a very simple definition of our segments. So we have a production segment, we have a development segment, we have a QA segment, and so on. And if you can just about see the trues and the falses, they're referring to whether or not you have to have permission, i.e. somebody has to accept the connection to that from another account. So then when we spin up this new account, if it's in the dev OU, we allow connectivity to the dev segment without any extra permissions being needed. So developers can get on, they can do their work, they don't need to do anything. We then allow connectivity between dev accounts in that segment. So we've not just used Cloud WAN to connect those two accounts together, we've actually used Cloud WAN to allow routing between the individual services in the dev. But now we want to move up the stack and go maybe into a test environment or into a production environment. This is where we want to start adding more controls in. Defense in depth again comes into play. So now we do require the other side, so in this case the Cloud WAN account, to approve the connection to the Cloud WAN system. Now, I also mentioned AWS organizations. That's really important for us so that we can use resource access RAM, resource access manager, I think it is.
Yeah, you were there.
To share, I always say RAM, I never say the full thing, to share services between the OU. But again, I want to control that and lock down. So at the top left, you can see I can actually specify which accounts are allowed to join and use sharing. Again, Cloud WAN enables us to enforce this. And then at the bottom left, you have the actual policy itself. So you've defined the segments on the right, how it allows it to connect. But over here, you then have the set of rules. So now we move into, say, a production environment, and I say, this account is allowed to talk to this account, or this VPC is allowed to talk to this VPC. And by doing this policy as code, compliance as code, or whatever you want to call it, it enables us to run faster. The brakes on the car, as we talked before. And Cloud WAN allows us to do that routing between regions, keeping segmentation between production and test, even between different accounts, completely separate, but all fully automated in terms of the deployment. The next tool we're going to talk about is something called AWS Lattice. Now, Lattice is a newer service. I can't remember when it actually came out.
About 18 months, reinvented before last, I think.
So it's been out a year and a half. So I haven't seen many people use it, and we're just beginning to experiment with it ourselves, but I already love it. So what Lattice allows you to do is have a client and a service architecture that no longer need to care where the service is. So if you're a client and you're sitting in one VPC and you have, let's say, an IP range and begins 10 or 11, you said 11 earlier, so 11.x. So we've got a service that's sitting in that IP range. We now want to consume that service from another account, maybe from a different OU, doesn't really matter. And we then connect a client service in Lattice to be able to talk to that AWS Lattice service. So that allows us to no longer care about the IP routing in between. So I don't have to set up a transit gateway. I don't have to set up VPC pairing. I don't even have to set up Cloud WAN. I can allow connectivity between my client, which could be Fargate, Lambda, any other modern cloud-native technologies, some cloud-naive if you really insist, to be able to connect to my servers without worrying about networking. I talked about infrastructure is dying and let's help it do so, that's another way in which we can do it. The problem we have at the moment is Lattice, as of today, doesn't support multi-region. And if you want to connect, say, from a region in the US to the EU or to Asia Pac, you need to be able to use Cloud WAN. So we're going to be using Cloud WAN and Lattice in combination. But just like Cloud WAN has a policy, you can do the same with Amazon VPC Lattice. You can put a policy in place. You can allow your services to be consumed by different identity and access management roles in other accounts, in the same account, doesn't really matter. It just enables it to consume it. So this client and service type architecture, it's as if you were, let's say, a Lambda consuming a DynamoDB through a private link. You can think of it like that. You're providing the DynamoDB in this example as another service within your organization, and then you're consuming it from your service, and you've got to provide the connectivity for doing that. But those two products together provide a very powerful way of helping to kill off infrastructure, to do compliance as code, and to hopefully eventually move everything to cloud native.
Yeah, and I must admit, it's one of my top 3 favorite services, Lattice, as well. Application-aware networking is the term that we use in that space a lot. So making sure that we're understanding at the application layer what's going on, and then building the networking to underpin that. So I'm going to move on to an example architecture. I'm sure it'll look vaguely familiar. It doesn't look particularly complicated, hopefully. This will be something that looks pretty similar to what you've seen before. But here we've got an SPA, a single page architecture application in an S3 bucket, fronted by CloudFront. We're going to go into an API gateway, Lambda, and then we've got both DynamoDB and Aurora on the back end. So I'm just going to talk about, after we've got our infrastructure pipeline that we've set up, we've deployed, and we've thought about how we're going to do our network controls to segregate ourselves off from the rest of the services. What are the other things that we need to just make sure we're thinking about when we're deploying our applications? So let's start off with my favorite AWS service, as some of my colleagues will normally laugh about, which is Amazon Cognito. There's a small cheer in the audience in case you couldn't hear it with the headphones on. So I'm going to use Cognito for identity management here, and then I'm going to log into an API gateway. There's a couple of different ways we can do that. I can do my authentication into Cognito, and I get back my JOT. Now this is an open question. I'll stand at the back at the end in case anybody can answer it for me. I know the RFC says JWT should be pronounced JOT. I don't know why. I ask this every single time I do a talk. So if anybody knows why, please tell me. I'm really curious to know. I get my JOT back from Cognito though that says who I am. I do my authentication. I type in a really, really long password and I get my JOT back. I then pass that into an API gateway. Now I've got a couple of different ways I can then use API gateway to evaluate that JOT. I could really simply use a Cognito authorizer on API gateway. And what that will do is it will check that that token was signed by the Cognito user pool that I've set up. But actually that is a binary, yes or no, it was signed by that pool. You can now get access to the methods that you've got running in your API gateway. What I probably want to do is I probably want to do a bit more of a fine-grained control than that. So I'll use a Lambda authorizer to validate that JWT. So I pass that JOT to it, and I use my friend Otto's excellent library, AWS JWT Verify, available in all good GitHubs. Now, what that is a single library, so there's no dependencies inside that library to do the validation of that JWT. But anyway, we validate the JWT, we check it's valid, we check that it hasn't expired, we check that it's from the user pool we were expecting. But then I need to write some logic into my Lambda to determine whether or not they're allowed to make that call they're trying to make. Let's say I've got a payment service, and Adrian's allowed to make a BACS payment, and I'm allowed to make a CHAPS payment. Yeah, I can evaluate that in the code at that point. Based off who I am in that JWT, are you allowed to call the method that you're calling? What I could also do though, I can write that in code, no problem at all. That works like a dream in Lambda. I could also use verified permissions, favorite service number 2, to actually go and evaluate that against an external policy. So the idea with verified permissions is that I can have an authorization policy that I don't have to embed into the code that determines that. So it will take the context of the call, it'll take the JWT, and then it says, based off the policy I've got, you're allowed to do this thing or not. And hopefully, you then get back your policy from the Lambda authorizer, and you're allowed or not allowed. We need to make sure, obviously, that we're thinking about how we protect our data at rest, because we always need to think about that. remember, in an architecture like this, we've got a few places where there is data at rest. So if I'm using the cache on API gateway, important to remember that you can turn caching on at the API gateway level, but you can only turn encryption of that cache on at the method level. So never forget that. You can encrypt that cache, but you have to turn it on yourselves. I need to think about the temporary data I'm using inside my Lambdas. Lambdas encrypt their storage by default, but the temporary, making sure it's not available to other Lambdas that might be rerun, is something I need to think about as well. And then obviously, for S3, Aurora, and DynamoDB, I can use KMS to help me do that encryption at rest. So I've talked a little bit about how we can do our application level access control on the API gateway. I can also do CORS checking. I'm sure anybody who's used API gateway and fought with CORS will not want to talk about that any further. It's sometimes a bit of a painful process. It certainly melts my head when I do it. The other thing I want to mention that's frequently forgotten on API gateway though, is API gateway can actually do basic request validation as well. So whilst you would almost certainly want to be doing, well, you will want to be doing input validation on your application, you can actually do that in the API gateway as well. And bear in mind, if it's getting filtered out in the API gateway, it's never getting as far as your app. In this case, Lambda, so I'm not charging, AWS aren't charging you for any of that compute usage to reject that request. So you can do simple validation. In this particular case, I'm defining that the price has to be between 25 and 500, yeah? But make sure you're still doing that validation at every level. I then need to think about access control into my DynamoDB. Now, here's a pretty simple example of how you can do access into DynamoDB. I promised you some IAM. This is where I'm going to apply that setting to my Lambda role. I'm going to apply this policy to my Lambda role. And I'm going to say that you can get item on the inventory table if you are that particular role. And that's great, and that's what lots of us have done for a long time. But it's important to think about where we can move that authorization down to the user level again, thinking about the application context to enforce my security. So in this particular case, we have an integration between DynamoDB and Cognito, where I can pass in a condition that says, for this Cognito user, they are allowed access to this leading key, which is the partition key, in that DynamoDB. So commonly where I use this is in multi-tenanted systems, where I make the leading key a tenant identifier. And if I have that inside my token, I can define a tenant identifier and say, you can only see these rows inside this DynamoDB table. And I can enforce that through this integration. I also need to think about how I'm protecting my S3 bucket. Obviously, if you create an S3 bucket, it is only you that has access to that once you first create that S3 bucket. Yeah, that's a really important thing to remember is, people get worried about public S3 buckets, but when you create an S3 bucket, only you have access to it in the first instance. You then have to apply policy to let other people have access to it. In this particular case, what we're concerned about is making sure that people can't go directly to that S3 bucket, because in our case, we're saying everybody's going via CloudFront to get to S3. So here we're saying we're going to set an OAI, which defines only CloudFront can call this S3 bucket. In a similar vein, we need to think about how we're accessing our relational database. So my function has to have a database username and password to get into that relational database. Now, obviously, it would be bad to put that in statically. I don't want to have that sensitive data embedded into functions and embedded into code. So whilst it's convenient that you can use environment variables to do that, that's not good practice either. The right answer in this particular space is to use Secrets Manager, or you can use IAM directly to do the access and the integration into those databases. So you would apply an IAM role to the calling compute to give it permission into that database.
And that's the best option.
That is the best option. Okay, don't forget on your Lambda, you've still got to worry about your standard Lambda application security problems. You've still got to think about OLC, I've still got to do input validation. I still need to think about what roles and policies I'm applying to that Lambda. Yeah, and I want to make sure that I'm scanning that for vulnerabilities. From a DDoS and cross-site scripting point of view, I'm going to go really fast because we're nearly out of time. DDoS protection, thinking about AWS Shield. So everybody gets Shield Common, Shield Standard, but Shield Advanced gives you that extra application level security as well. So whilst that's the charged for model, that does give you an extra level of control over and above what you get in Shield Standard, And also you get the Shield response team to help you in the event of there being an incident. So they'll help you write WAF rules to make sure that you can apply them to avoid any DDoS problems you're having.
And obviously that means you've got to have the WAF already in line so that you can write the rules for it.
Exactly. And if you've got a WAF, well, you might as well have a rule set running on it as well. So you can use managed rule sets, or you can build them yourself. We also need to have a little think about how we're protecting against SQL injection there at the back end, because I'm not going to run a WAF all the way back there behind my function. So I still want to think about using prepared SQL statements to make sure I'm minimizing my security, my SQL injection risks.
Or command injection to DynamoDB.
Or command injection, thank you. So making sure we're thinking about security at all layers is the point of this example part at the end. We're thinking about it all the way through our development lifecycle. We're thinking about it all the way through our infrastructure as code lifecycle, and then again when the infrastructure is in live as well. So hopefully that's been helpful. The key things to take away is when you're thinking about applying as much automation as possible is the best way to avoid manual misconfigurations and errors. Think about how you can use IAC with a similar set of controls to your application development process. And make sure you're applying your security at all layers throughout your application. You can use some tooling that will help you, and some of those are what we shared today. But the earlier to the left that you can detect problems, the cheaper and faster it is to fix them. The more you can reduce that misconfiguration and consistently enforce those security measures, the safer you're going to be. I'm going to try and leave that up for a second or two, just so you can see if you'd like some follow-up on this, but obviously the slides will be around afterwards as well. So just from Adrian and I, thank you ever so much for your time and attention this afternoon. I hope you're having a good summit and enjoy the rest of the day. Please don't forget to fill out the survey.